Welcome, my name is Spyros Zigouris. I am a computer science professor and you are on videolearner.com. Through this channel you'll find complete lessons and explanations for the International Baccalaureate Diploma program in computer science.
Hi guys, let's move forward to our next lesson. Today we're going to see how CPUs and GPUs collaborating to perform computations together. CPUs and GPUs need to work closely together to achieve efficient task execution. Understanding their interaction is essential for optimizing performance. As we've already seen in previous lessons, CPUs are built for general-purpose processing, while GPUs are built for handling parallel tasks. General-purpose processing involves executing diverse instructions with complex logic and decision-making, whereas parallel processing performs the same operation on many data elements at once. A helpful analogy is a professional restaurant kitchen. The head chef, the CPU, oversees and coordinates everything, while specialized cooks, that is to say GPU, focus on high-volume, repetitive tasks. We'll now continue with the next part of the course and see how tasks are typically divided when CPUs and GPUs are working together. So let's talk about task division. When CPUs and GPUs collaborate, tasks are usually divided according to their characteristics and demands. The CPU handles sequential and control-heavy tasks, managing the system, executing logic and control operations, and processing tasks that involve frequent decision-making. Examples of CPU tasks include operating system management, network communication, and input-output operations. Data-heavy tasks that can be parallelized are assigned to the GPU, which can execute hundreds or thousands of independent operations at the same time. Examples include matrix multiplications in machine learning, pixel processing in graphics rendering, and data analysis in scientific computations. Now let's move on and see what happens with data sharing and synchronization. Effective collaboration between CPUs and GPUs requires efficient data sharing. Data is first stored in main memory, accessible by the CPU. To be processed by the GPU, it must typically be transferred to the GPU's memory via the PCI Express bus, which can create a performance bottleneck. Certain architectures provide unified memory, enabling both CPU and GPU to access the same physical memory, reducing transfer overhead and simplifying data management. The last thing we have to deal on today's lesson is synchronizing task execution. Managing execution between CPUs and GPUs involves programming frameworks, that is to say kernel languages, such as CUDA platform for NVIDIA GPUs and OpenCL. These languages offer tools to control task distribution, memory management, and synchronization between processors, often using primitives like barriers or events. Contemporary systems can dynamically assign tasks to CPUs or GPUs based on workload and task characteristics, optimizing both performance and energy efficiency. A barrier is a synchronization tool that ensures multiple threads or processes reach a specific point in execution before any can continue. It can be visualized as a checkpoint in a race that all runners' threads must reach before moving on. In parallel programming, barriers create a synchronization point where threads pause until every participating thread has arrived. Once the final thread reaches the barrier, all threads are released to continue their next operations. An event is a synchronization primitive that lets threads pause until specific conditions are satisfied. Unlike barriers which coordinate a group of threads at a fixed point, events offer more flexibility by signaling one or multiple waiting threads when a particular condition occurs, such as task completion or the availability of necessary data. And that's all for now. We finished. In the next lesson, we will describe functions and roles of various types of primary memory, especially we're going to deal with registers, and after that with cache and ROM and RAM. From Spyro Zigouris, my YouTube channel, and videolearner.com. Bye bye.